In this video, we're going to be talking about our second method of solving quadratic equations, and we're in this case going to use what's called the square root method. Okay? And the square root method is only useful in very, very specific circumstances. So here's the circumstance. If you can say that there is no middle term, and here's what I mean by middle term. If I were to give you an example of something that does have a middle term, I would say something like x squared plus 7x plus 10. I would say that this x to the first term is usually what we refer to as the middle term, right? So if I were to not have this in my problem would look like instead x squared plus 10. So really what I'm getting is a binomial. It's got two terms. The x to the first term is missing. That's when we're allowed to use this method, and that's it. Okay? If there's a middle x term, x to the first term, I can't use this. So this is, again, for very special circumstances. But the nice thing is it makes our life a lot easier than having to try to factor. And in some cases, factoring won't work, but this will. So we kind of need it as a backup plan if we try to factor a binomial, but it doesn't work out for us. All right, so in this first problem, here's how I could solve this binomial. Right? I can just solve this like a regular old equation. Let's get the x squared alone, and then we'll square root it at the end. So I'm going to add the 16 over, and it'll say that x squared is equal to 16. Okay? And then to get rid of a squared, its opposite is square rooting. So I'm going to square root both sides. Squareds and square roots cancel each other out, so they will both disappear, and I'll just be left with x. That means that I've solved the problem. I have x by itself. That's what I was trying to do. The square root of 16 has two answers, 4 and negative 4. So if you remember from the factoring video, we said instead of writing two separate answers, I can just say plus or minus 4 represents both of those solutions. Okay, so this is, again, useful for these types of problems where we can just solve it like we learned how to solve good old linear equations. Okay, so let's go through and do a couple more. So in this case, I'm looking at this and I'm saying, okay, no middle term, so I can use this method. Let's add the 24 over. Our goal is to get x squared alone. So it'll look like 3x squared equals 27. Okay. I'm going to divide away the 3. I do not want to square root until x squared is the only thing that's there. So I'm going to divide both sides by 3 and get that x squared is equal to 9. And now I'm going to square root, and squareds and square roots cancel, so this is x. Square root of 9, again, don't forget, plus or minus 3. Okay, so I'm going to say that is my solution. And then my last one, kind of something funny happens. When I subtract this 9 over to get it by itself, I get that x squared is equal to negative 9. And then I'm going to say let's square root and square root. Okay, and here's where I run into the problem. X equals, okay, well, what's the square root of 9? We don't know yet, so we're kind of say, sorry, I can't give you any answer. So for right now, we're going to say there's no solution. Again, in a little bit, we're going to learn how to do the square root of negative numbers, but we're going to hold off right now and say right now there's no, and if you want to kind of put a word in here that's technical and what we'll use, we'll say there are no real number solutions. Okay, I can't give you a useful, helpful value that represents the square root of negative 9. Okay, so we're going to say there's no answers because I tried to square root a negative, and that's bad. Okay, so we're going to skip that and move on to a quick word problem. So in this word problem, I just want to point out that this is asking about giving you a lot of information. But when I look at this, here's what they're describing. They're saying, all right, you climb to the top of a building. Okay, and you are dropping an object from a 500-foot roof, and you want to know how long is it going to take for it to be at 200 feet. So I'd look at this and say, okay, 500-foot roof. They want to know how long does it take to drop from 500 down to 200 above the ground. And they're giving me an equation that represents height. Right? So they're saying if you want to know about height, okay, if you want to know about time and height and how they're related, use this equation. So that's my big important one, so I gave its own highlight color. Okay, so here's what they told me. They want to know about a height. They're giving me the height of 200 feet. So I'm going to go up to this problem, and it tells me in my problem that h is height. So if they're telling me that h is height, and I know that for my problem, I care about 200 feet, I'm going to rewrite this equation, but put a 200 in for h. And here's the nice thing. They asked me specifically about time. Approximate the time, which means how much time. So they're kind of saying for t, we don't know. So that's why in my problem that I'm going to solve, I'm going to leave t as a variable, because we don't know how much time it takes to get to 200 feet. So I'm going to now just solve this like we did on our last one. I want to get t squared alone, which means start by subtracting the 500. So now it says negative 300 is equal to negative 16 t squared. And now I want to get t squared alone. I do not want to try to square root. when there's a negative 16 there. So I'm going to pull up my calculator real quick. 300 divided by 16 is 18.75. So I'm going to say 18.75 is equal to t squared. And just as a note, it is a positive number because I did negative 300 divided by negative 16. And two negatives make a positive when I'm dividing. And so now I can square root. So I'm going to square root on the left, and I'm going to square root on the right. Okay, and I'm going to take the square root of 18.75, which is, it says 4.33. Okay, so I'm going to say t equals 4.33. Okay, and it tells me up top here that time is in seconds, so I know that this is 4.33 seconds. Remember, square rooting technically gives us a negative answer, but I'm not going to keep that one because there's no such thing as negative time. Right? It doesn't make sense in the context of measuring time. So we're going to say just keep the positive 4.33 seconds. So we can expect that when we let go of this object, okay, at 500 feet, that in 4.33 seconds, that object will be at 200 feet above the ground. It hasn't made it to the ground yet. It's still kind of hovering at 200. Okay, so that's something to keep in mind. So in the context of a word problem, this might look a lot more complicated, but we didn't do anything different than we did just a minute ago when we were just looking at problems that were not a part of word problems. We just had to plug in the correct value before we started solving, but we were able to do the same kind of solving when we solved this. Okay, so let's take a look at one more type of problem, and then we will be done with the square root method. So in this type of problem, okay, I see a squared, and I'm wondering, like, well, what method do I use here? And I think what a lot of people want to do is they want to do x minus 2 times x minus 2 and get rid of the parentheses, or x plus 5 times x plus 5. So we don't want to do all of that work. That seems like a lot of work to do. If there was a nice way to do this without doing all that foiling, we want to try to make our life easy. So what we're going to do for this problem is we're going to kind of look at the parentheses as if it was just x. If this just said x squared equals 25, and I asked you to get x by itself, you would just square root immediately, right? We get rid of all the stuff outside of the squared, then we square root. So I'm going to look at this problem as the same thing. I'm going to say x minus 2 squared. I can just square root this whole thing on both sides, right? So now when I square and square root cancel, it doesn't leave me at my answer. The square root of 25 is 5. I still have a little bit more work to do, but I got rid of the squared, which is what I wanted to do. So here's the catch. We got to remember that square root of 25 has two answers. So x minus 2 could be 5, or the leftover under the squared could also be negative 5. Okay? So I'm going to get my two answers. When I add 2 here, I get 7. And when I add 2 here, I get negative 3. So I got two answers. Okay? And I didn't have to do all the foiling. I didn't have to do x minus 2 times x minus 2 and set it equal to 0 and I didn't have to do all that work. I just got the squared by itself and I square rooted, which is exactly what we did on the other problems that were a little simpler. Okay, so here's another one. So here I can't square root immediately because I have on the same side as the squared, I have this plus 13. So my first job is let's move that away from the squared. Again, think about it, if it was just x squared plus 13 equals 14, what would you do? I would subtract the 13 and square root. I'm going to do the same thing. Okay? So I'm going to say leave the x plus 5 squared alone. Subtract this 13 over, it becomes 1. Now that x plus 5 squared is the only thing on the left-hand side, I can square root both sides. So now it says x plus 5 equals 1, or x plus 5 equals negative 1. Right? Square root of 1 has two possibilities. So I need to now solve this. I'm going to subtract the 5. I got to finish get x by itself. Get a negative 4, and I'll get a negative 6. And these are my two solutions using the square root method. Again, saving me a lot of time having to simplify that. Okay? So I think I have one more for you to look at. Okay? So take a look at this problem. This might blow your mind a little bit. Okay, if I'm looking at this problem, x squared plus 16x plus 64 equals 25, I think what most people would immediately try to do is set it equal to 0 and factor it. And that would be entirely okay and entirely accurate, and you would get the right answer. But if I can rewrite an expression so that it is something squared, that means that I'll be able to use the square root method. So if you notice the left-hand side, this is really, if I were to just factor it without it being equal to 0, this would actually turn into x plus 8 times x plus 8, okay, equals 25. When you might say, well, like, that's not something squared. But if I repeat multiplication, like if I did 7 times 7 and I repeated the same number in multiplying, I could write that as 7 squared. So I can do the same thing here. X plus 8 times x plus 8 is x plus 8 squared, right? And so I can use the square root method. Now that I've turned the left-hand side into something useful, I can say, let's square root and square root. So either x plus 8 is equal to 5, or x plus 8 is negative 5. And so I get two answers. It looks like when I subtract 8 on both sides here, I get a negative 3. And when I subtract 8 on both sides here, I get negative 13. And I have my two answers. So we didn't have to go through setting it equal to 0, trying to factor and doing all that work. We were able to kind of quickly turn it into a squared form. And once it's in that squared form, we are able to use the squared method. So it is useful in a lot of ways. You just have to maybe think outside the box in order to do it. But again, big idea. If you have something squared, no x to the first term sitting by itself, you can solve it like a normal equation, get that squared alone, and then use the square root in order to solve your problem.